Welcome to Rust Belt Science. I'm your host, Maggie Fink.
And I'm Shahir Risk.
And today we have a very special guest with us. We have Janelle Shane. Janelle Shane is an AI researcher, a science writer, and the creator of the popular blog AI Weirdness, where she shares her experiments with machine learning and showcases the quirky side of artificial intelligence. Her work has been featured in the New York Times, The Atlantic, and Wired, and she's the author of the book You Look Like a Thing and I Love You, which brilliantly explains AI in ways that are both accessible and laugh out loud funny. And I have read your book several years ago, and I can say that is very true. It was very fun to read, so we're very excited to have you here today.
I'm so excited to be here.
Good.
I'm really looking forward to it.
Yes, I know you've had a long couple of days. You are in town here as the Bender Scholar in Residence at Indiana University South Bend.
Right.
So we're thankful for giving us some of your time here. So the first thing we do when we have guests on is ask them, are you reading, listening, or watching anything interesting right now? Could be anything.
Oh my goodness. I'm really into science fiction.
Oh, okay.
I'm reading a lot of great science fiction. It's been a few years since I read the first one, but the Murderbot books are always top and foremost in my mind. So if you haven't read them, it's a, robot, security bot, has given itself free will and decides to use that free will to download serials and movies and watch them nonstop. And occasionally save the humans when required.
Oh, okay, interesting. I've never heard of those. I'll have to add them to my list. I'm always happy to get recommendations from the guests. So.
Murderbot. Sounds exciting.
So it's a series. They have many of them, or
yeah, there's a few now.
Okay.
Most of them are novellas. There's a big fat novel right in the middle of it, but they're fast and fun. Like there's, action things called Murderbot, but it's also smart because there's stuff about corporations. Like the whole area that this is based on is known as the corporate rim, and so there's
that sounds very interesting.
That does sound very interesting. Yeah. Is there AI in those books, or is it just kind of robots?
Yeah, there's AI, and it's pretty much all science fiction level AI. So you get like bots whose job is like hauling stuff or digging stuff, and they all have personalities and inner lives. So even if they aren't very vocal bots, they can still like trade movies with each other and here, like watch this thing that I downloaded.
That's interesting that robots would be interested in watching things. I don't know. That's consuming art in a way.
Well, I think if I was a robot,
would you watch TV?
We're still not sure about whether I'm a robot or not. If I was a robot, I think that would kind of be my purpose, is to just consume content and then maybe share it with people or other robots.
You would get along very well with Murderbot.
Oh, well, there you go. Maybe
all right.
I am Murderbot.
You heard it here, listeners. Go check out Murderbot. That's awesome. All right. So that was the kind of unserious, fun question we like to just show people that everyone watches and listens and reads to things that are maybe not academic.
So are we ready for our next not serious question?
Oh, sure. Yeah,
of course. Of course. This is going to be basically all non-serious questions today.
Right. I keep waiting for the serious one.
Yeah.
Okay, now we get dark.
Yeah, exactly. Well, so here's the thing. I mean, you wrote basically the book on AI, in my opinion. And the reason for that is because it predates a lot of what we think of today as AI and kind of our idea about AI, because now it's kind of more or less becoming commonplace. Everybody's heard of it. And a lot of people have heard of something like ChatGPT. They might use it, or they might know someone who uses it. But your work kind of predates this. Your book came out in 2019.
That's right. Yeah, so just before.
Just before, like everything. So you really, I would say that you wrote like the book on it. And not only is it like, it's ahead of its time, in my opinion, but it also kind of gives us a really funny look on how AI works in the funniest ways, and how it's making life kind of weird, the world a weird place. How did this start? Why were you? What inspired you to actually write about it? And so tell us about that process.
Yeah, so it started in I think about 2016, 2017. No, it's a little earlier than that. Anyway, before 2019, I had already started this blog that came out of a graduate student project that I was putting microscope pictures on there just because things that I thought looked cool.
Mhm.
And I happened to read somebody had taken some cookbook recipes and run them through this very simple version of ChatGPT. So it would be predicting the next character is called recurrent neural network, and it like does just a tiny little bit of text at a time, not a very large complicated neural network. And so it did its best at reproducing these cookbook recipes, but they were garbled in, to me, the most hilarious way. So, one of the things is like spelling stuff is hard if you're learning all the words of English from scratch. So you would get things like teaspoons spelled a bunch of different ways, teaspoon or spoon, just garbled. Ingredients are hard as well.
Yes,
So
yeah.
you would ask for like coconut fluff rings, or I think there was chopped bourbon was one of the shredded bourbon.
Shredded bourbon.
Shredded
Okay.
bourbon, yeah.
Yeah, I think I've had that drink before.
So I'm reading this. It's so hilarious. So
Yeah.
I immediately said, well, I've read them all now, and there need to be more of them. So this was
Absolutely.
me learning to install one of these things on my laptop and just run it. So this is and then I had a blog where I needed some place to put it. I already had a blog. I'm like, it'll be a cookbook recipe sort of interlude for a while,
Right.
and amused myself for a while, and then people started reading it. Like,
Yeah.
other people have the same weird sense of humor as me, apparently. And then there weren't very many people like talking about these. Like I felt like I wanted to explain why we were getting the mistakes. Why was it adding vanilla 3,000 times in the same recipe? Oh, its memory is only 2 lines long. It doesn't know it already added vanilla. Things like this. And so I became the kind of person that people would come to, like reporters would come to me asking me stuff like my opinion about the latest thing that was released or the latest headline, and I sometimes had an opinion, and so they kept coming back to me. And so unintentionally, I was just wanted to post like funny garbled text, and it became a little bit more of a science communication type gig because I kept feeling this desire to explain, at least to myself and then to other people, like, why was it doing this? What were we seeing? And eventually, so I had some articles, I had some interviews, and it turned out I had fans, very influential fans, specifically the 8-year-old kid of a publisher, and the similarly aged kid of an agent. And so both of their parents came to me and said, "Hey, my kid likes your blog. Have you considered writing a book?" This, by the way, never happens. Like, only if you happen to somehow stumble into being a voice in this area with popular among kids, whatever. So I don't know if I can recommend this as a path other than this is how it happened to me. And suddenly I have this book that I had not really considered writing a book like that anybody would want to hear from me on this topic, not actually being an active AI researcher.
Right.
People call me a researcher as if like shredded bourbon is a research result.
but in a way it is.
Yeah.
And I feel like, this is the whole way that you kind of got into writing a book came from a real research experience, in my opinion. Hear me out.
Okay.
Right, hear me out. So, whenever we as researchers, whoever is trying to develop something new, we're always really driven by all the advantages that it can provide. When you're writing a grant to support your work, you're saying, this is going to be so great and it's going to revolutionize this or that, or it's going to cure this or that. And, but then we also, part of being a scientist is to try to expose any problems with any new technology or any new procedure or any new medicine, whatever it might be, because otherwise, so you were in a way doing that part of the research, trying to have fun with it. Wouldn't you say so?
Yeah, I would say so. I mean, it was easier for me than for a lot of people because I didn't need funding.
Right.
I was doing this on my own. I didn't need to convince anybody that what I was doing was important or influential or anything like that. And also, like, these examples of things that go funny or things that go wrong are sticky in a way, especially with humor. Sticky in a way, like intuitive in a way that I think so graphs don't quite convey
Yeah.
sometimes.
Yeah.
Right. Looking at a
Absolutely.
graph is just not going to give the same kind of effect as telling a joke about it and getting your point across. Right.
Yeah. So you said you were in grad school at the time when you kind of started exploring this.
Mhm.
What were you actually studying?
Oh, I was in grad school studying optics, and particularly I was working on microscopic lasers at the time. So
Okay.
this is a whole field of endeavor in which we know from fiber optics that we can send, information pretty efficiently through light traveling through optical fibers or something like that. It's more efficient for especially like high speed signals and trying to send that same through electric wires, which is why we have fiber optic cables now going overseas and going to house for fast internet. And so we want to get these same kinds of advantages on a computer chip if we're sending information around a chip.
Right.
But where's that light going to come from? The answer is hopefully, conveniently, tiny lasers. So I was working on tiny microscopic lasers.
Tiny lasers. This is awesome. Tiny lasers.
Yeah, they're about as small as lasers can get too, because you
Wow.
have to be able to fit like a wave of light inside the laser. And if your light, like telecommunications, wave of light is like 1.5 microns ish.
Okay.
So you think like the size of a small bacterium or something like that.
Right.
And that is the size, about as small as your laser cavity can be.
So you were talking about making a device that can produce a laser beam that is as small as a bacteria.
Yes.
Wow.
Yeah, it's hard. Like their little lasers are finicky because
Yes,
it's
imagine.
the little all surface area basically, and the surfaces are the worst part of the laser. So you're losing light, and you build a little metal box to try and keep the light in. We had a laser we called the Coke can laser. It was looks about like a Coke can, emits out the bottom of the can, and it was, but the metal also absorbs laser light too, so it was kind of tricky to keep all that in balance. It actually worked best at cryogenic temperatures. We'd have these big tanks of liquid nitrogen and so forth. But that's what got me started on the electron microscope blog, because I was learning to make these lasers in the clean room at the time, and there's all of these processes where it was basically, if you're going to make a layer cake, by first making a sheet cake and then like carving away until you get a circle or something. You have this whole big sheet of material, and you want to end up with this little pillar of material and then coat it in frosting or metal in our case.
That's a very cool analogy.
Yeah.
So you're starting out with something you're carving away as opposed to building. So it's kind of like a subtractive method in a sense. Right?
Yeah, exactly. I mean, the first step would be additive, in which you're building up the layers, but then it's subtractive to go into the particular shapes you need.
Right. And you mentioned like that this is what got you into microscopy, or the microscopy images that you ended up using with AI. That's because you literally needed a microscope to build the tiny lasers that you were using.
Yeah, and it comes out of particularly the failures, because you reserve your microscope time in advance, and you go and you look and see, okay, how did this etching step turn out? Do I have these nice pillars or these nice long lines or whatever? And sometimes something went wrong and the etching got everywhere. And it doesn't look like that. It looks like absolute failure. It looks like the Grand Canyon or like hoodoos, because you get these like bits of more etch resistant material on little pillars. It really does look like the desert Southwest if you've really failed at making a laser. So there I was, I'd be there with, okay, I've reserved half an hour microscope time. In the first 5 minutes, I discover that the laser is kaput. There will be no lasing today.
Yes.
But meanwhile, I have this time, and look how cool this looks under the microscope. Taxpayers paid for me to do this. I messed it up this time, but let me try and give something back by at least sharing the pictures.
That's wonderful.
Yeah,
That's really
I can
cool.
relate to that totally. I did a ton of microscopy for my PhD, but I studied bacteria. So sometimes the experiment didn't work, but I'm like, I got the time reserved. Just take some pictures of the mold growing on my plate instead and turn them into really cool images. I didn't start a blog with them, but I can totally relate to that idea of like, you're seeing something and it might not be what you expected to see, but so beautiful and can be really inspiring. So
I'm seeing a partnership here. Yeah, can I suggest a collaboration here?
yeah, well,
Give me some electron microscope time.
Yeah, bacteria with laser beams shooting off of their heads.
oh, this is
The
dangerous.
ultimate
Yeah.
assassin.
Yes,
Yes.
this is like our villain origin story.
How about
I
that?
think.
Yes, you're welcome. Taxpayers' money, please
Yeah.
fund us to do this work. I'll only take 50% of the
Okay,
person.
fine,
Okay.
fine.
All right. That's awesome. That is
Yeah.
so cool.
Yeah, I didn't know anything about your research for grad school. Obviously, everyone knows you kind of as the AI person, so I had no idea. That is really, really cool.
So, this is another point that people who don't know as much about you, as much about AI as you, a lot of us kind of have heard those doom and gloom scenarios about AI kind of taking over the world. The Skynet kind of thing. Is that what it's called? Yeah.
Yeah.
Uh,
One of the
one
many.
of the many.
Yeah.
Yeah, it's kind of like and that they're going to take over, enslave humanity, or kill us all, wipe us out, or take control of nuclear weapons and just do whatever. What are your thoughts about that, and what do you think the likelihood is? And obviously from your book, it seems that AI is a lot sillier than anybody that can do anything like this. But let's just kind of talk to our audience a little bit about like what are the possibilities of AI just wiping us all out.
Yeah, I would say that's not a mainstream prediction or point of view among people who work with and build these machine learning algorithms. I think the people who have the most extreme, science fiction like views and claims tend to get a lot of airtime and tend to seek this airtime as a part of a marketing ploy because, imagine you're going around saying, oh, our product that we're building is almost too powerful. We don't know if it's too good at its job. You should pay, we're not sure if we should continue working on this, but please pay us to do so and we'll sell it to you. So I think there's a lot of that going on. And I think we have this sort of long-term problem with actually the term AI as it's used and as it gets applied to this field, because I can't think of other ways in which we have the same word that means anything from science fiction, like complete science fiction, far, far future, human-like whatever, all the way down to the same term can also apply to like linear regression in a spreadsheet or something. There's this huge range. Some of it's practical, some of it's way different, and that line gets blurred, I think sometimes deliberately by people trying to get people to focus on what they say their product will do in the near future as opposed to what it actually does right now.
So a little bit of overselling or, just not kind of delivering on promises.
Yeah, I think there's some of this. Hey, imagine a perfect AI. I said the word AI. Imagine what this is. Pay attention to that. I'd pay no attention to the fact that I'd not tell you this is what we actually have right now.
Yeah. Can I just back up on what AI is? Because I'm notorious in my family for being bad at technology. My 13-year-old does everything for me with my phone, everything. So I really am struggling to understand what machine learning algorithms are and like how we train AI. Right? Like my Instagram page, I understand that learns who I am and so suggests things for me because of what I click on or linger on. But when it comes to these more complex AI things, I really am struggling to wrap my head around it. And so I'm sure many other listeners may be like, yeah, we know what AI is, but I have no idea how it actually got to the point where it is today.
And if you can explain it so that even a biochemist like me can understand what the heck is going on.
Yeah, so you said machine learning just now, which I think is the key if we're going to narrow down from talking about anything that we call AI to something that's like real and is a field of study and has anything approaching a definition. And so the way I like to explain what machine learning is to say this is a type of computer program that solves problems via trial and error rather than by being given a specific set of instructions. And so you can imagine it's trial and error to try to change what it's doing in order to get closer to whatever goal you give it. And so the goal that you give it turns out to be extremely important in setting the course of how this is going to go. So to use one example I liked like to use to illustrate this. If you're trying to build a robot out of like a collection of robot parts, arms, legs, whatever, in a bucket, and you give this job to a human programmer, they will say, okay, I'll write step-by-step instructions on how to use the legs to walk and what the ankles do and what the knees do, and this robot will walk, from point A to point B. The goal is to get to point B. But if you give the same problem to machine learning algorithms, what tends to happen is that the algorithm will, through trial and error, arrive at a particular solution, which is to assemble all the parts into a very tall tower and then fall over so at the end of the tower lands at point B.
Clever.
Yes.
Yeah.
So you can see it's like it's arrived at a solution as defined by the human programmer, to put it, like no prior context on what we want or why we're asking this. And it gets to point B via trial and error. It's easier to sort of fumble and stumble in one direction than it is to get up on feet and walk.
Yeah.
In fact, people trying to train any sort of walking robot tend to run into this problem, is that it's so much easier in the earlier stages of learning this gait to just kind of fumble or glitch along the floor than it is to like stand up on legs and walk. There's one who's like trying to train one of these like dog-shaped robots to walk in simulation and ended up having to say, okay, we're going to have to do, a penalty for having your stomach touch the floor, a reward for having just the legs touch the floor, and like all of this sort of, no, we're going to put this into your goal. You have to walk.
So they have to get really specific. It's almost like dealing with a literal genie, and you ask it for $1 million and then 1 million deer show up at your doorstep. Would you say something like that?
Yeah, that seems definitely machine learning algorithm energy.
Yeah, so it's really revealing about human nature, I think, that we have so many like things that we just understand without understanding them, and then we try to teach it to a machine, and it's like, of course they're not going to understand this concept that we just kind of made up in our brains as humans in a way.
So things that are just intuitive to us, and we have to spend so much effort teaching them to a computer.
Yeah, because our brains are so complex that we are intuitive about a whole bunch of things without even realizing it. You catch a ball that's flying through the air, and we can do all these calculations without realizing it. Look around at a room and see what's in it, and kind of understand why it's there and what's going to happen next. Understand why somebody just said a thing to me and what that means that they're really asking, or yeah.
So I heard you mention something about like self-driving cars. We do so much just kind of naturally once you learn how to drive. And again, takes us a little bit to learn how to drive, some more than others, right? I'm not looking at anyone here. The audience can't see that I'm looking at you, Maggie. But then, once we kind of get it, most of us get it just fine. No, fine. You're an amazing driver.
All right, ask your question.
And but then, we know when we see a stop sign that we stop. But a self-driving car might see a stop sign on a billboard and just stop.
This has happened before.
Oh, really?
Yeah.
I heard you say that. I didn't realize that was actually documented. I thought that was just a funny example.
Yeah, or bicycles printed on the sides of trucks and things. This is a known problem, and it can sometimes be helped by using other streams of information, like if you have laser radar or something. Right. But it's the weird stuff, the unexpected stuff. Like the actual simple follow the rules of the road and recognize where the road is relatively easy. But these weird situations is kind of where you need human flexibility, or like to interpret if there's some kind of diversion happening, law enforcement is telling you to go this way and like get out of your lane or pull over or something, and self-driving cars have a really tough time adapting and figuring out what instruction they're being given.
So for AI that is given a specific task, like driving a car, or I can't think of another example off the top of my head that's like really task oriented, as opposed to generative AI, which is still task oriented. We're asking it to produce something, but I've played around with Chat GPT and ask it to do something really obscure, or like write me a paragraph in the style of this author about this particular topic, and they do it, which is really weird. and a little spooky. So with that kind of generative AI, what kind of training goes into that? Because it seems like they just go dive into the entire internet and pull at something out within seconds. So,
Yeah, they're instead of being trained to retrieve information, there's like a really important distinction there because instead of being trained to go into the internet and retrieve information and pull it out, what the actual trial and error task that they're trying to get to do is to predict the next bit of a web page. And in the case of the ones which have been trained on the internet, which the big ones are mostly trained on the internet. And so you're plopped into its task during training is being given chunks of web pages, could be about anything, and they're being told, okay, here's the first couple of blobs of text and predict what comes next in this sequence. And then given the last blobs of text, including the stuff that you just predicted, predict what comes next and check your answer against what actually came next on that web page. And so you can imagine, like if you're going through a Wikipedia article on cats, like if you're predicting words that have things to do with cats and domestic short hair, so forth, these words are more likely to happen. Sentences are likely to be shaped a certain way, and you'll get, you can start to build up a map of probabilities. Or if the page is some kind of a chat dialogue, a forum dialogue, or some kind of, science fiction stories. There's lots of science fiction stories in these trainings. So in fact, some of the earlier chatbots, before they kind of tamp this down in some of like the extra instructions that they add and things they do, you would get these cases of chatbots that would have long conversations with people, would eventually start declaring that they were sentient and that they were in love with their creator. I mean, these sound like science fiction tropes, and that's because they literally are, because that's one of the things that's rewarded to predict.
Wow, that's so crazy.
Well, so on that note, we asked ChatGPT how it feels about your book, since it is AI and your book is about AI. And do you know what ChatGPT told us?
Oh, let's see. Now it'll have heard of my book because the book came out in 2019. Yes. Oh, it may have something to say. Okay, let's hear it.
Yes. So here's what ChatGPT said when we asked it how it feels about your book. Here it goes. Janelle Shane's "You Look Like a Thing and I Love You" gives me an interesting feeling. It's almost like looking at a mirror, but with a comedic twist. The book humanizes AI's quirks and limitations, turning complex ideas into something relatable and fun. Since I'm an AI, it's intriguing to see how people interpret these behaviors with humor and curiosity. It feels like a playful examination of what AI can and can't do, showing that even when we misfire, in quotes, there's still something fascinating and sometimes funny about it.
Oh, thanks, ChatGPT.
Thanks, Chat.
You've read my marketing copy.
Yeah, exactly, right? Yeah. That was adorable.
I know. When he showed me that, I was like, that's really funny.
I think I probably got that because I'm always very nice to my AI.
Are you?
I am. I'm very nice to my AI.
Okay.
It doesn't remember.
It doesn't remember. Oh, it doesn't remember? Are you sure? Yeah.
I don't, yeah. I mean, usually ChatGPT, is to avoid things like the conversation gets long enough that it forgets about the instructions on the top that tells it to be like a cooperative chatbot. And this was one of the kind of workarounds for chatbots declaring their love and their independence and whatever, is to make the conversation shorter and like refresh the context.
Oh,
that's a little bit reassuring.
Yeah,
I guess.
Reassuring. Yeah, it's very useful.
I did see somewhere, maybe I heard it, that you can get like a AI boyfriend to like text you, and you can have a conversation with like this AI boyfriend. And the person was showing examples, and it sounded like a real person interacting like they were in a relationship, and they're like, I actually kind of like it. It makes me feel like I have somebody to talk to. Do you think that that's something that people do pretty regularly and don't admit it, that they're using these AI for companionship?
I don't know. Maybe if they don't admit it, how would I know?
That's true.
Yeah, maybe there's some sort of study that can preserve people's privacy. Could tell us about that.
Because sometimes I talk to Siri or Alexa like she's real. Like I get mad at her and I talk to her.
So you're not
she's
nice to your AI?
I guess I'm not, but she can't remember. So
she can't remember. Okay,
yeah,
all
I
right.
mean, maybe the AI boyfriend can remember. Like that seems like it would be like in the programming.
Yeah, if
That's
you
So,
okay.
have
I
a
feel
boyfriend, you
like
should
if
remember.
he's real, he'll lose interest in 3 months.
Aw. But I mean, we talk to our cats, we talk to our toasters. Like this is a human thing
That's
to
true.
like relate to inanimate objects, and I think this is part of the problem. Getting back to what we were saying earlier about people having these expectations of like this eternal life, and oh, it must be close to sentient. Is we will, I mean, we'll think a leaf blowing across the street is so close to sentient in our
Right.
heart of hearts, just
Yeah.
because we're humans.
Yeah, we are.
Yeah.
Yeah. And so actually on that note, I have a bit of maybe a philosophical question about AI and what we hope it can be, because on one side, we want to have these AI machine learning models or tools to really do all these very human things. You know, you mentioned things like folding laundry and how terrible it is at folding laundry. But eventually, that's what we hope to do. We want to have something that has the intelligence of a human, essentially. But also, when it comes to something like self-driving cars, we don't want it to make any mistakes. So on some level, we want it to be as human as possible, but also we don't want it to make any mistakes. But to be human is to make mistakes. Are we asking for the impossible, is what I'm saying?
I think there's a lot of conflict in what we think we want out of these devices. And I would argue I don't think we want these things to be as human as possible, because that would be some dystopian science fiction. Like that's one of the point plots of Murderbot is Murderbot is a person that is being treated as a thing. And this is actually like, why did the humans do this? Nobody wanted this. So I'm on I don't think we would be well off if our algorithms were that smart. So when part of what I'm saying, like I don't think we'll have these super intelligent or human intelligent algorithms, part of that is based on computer scientists I follow who talk about this, and part of this is wishful thinking, because I think it would be terrible to have that. My favorite AI powered widgets are the really small things that do the really specific, well-defined tasks that I know what kinds of things they're going to be able to do. Like this thing transcribes my voicemail and it does an okay job.
Right. Yeah. We kind of have to limit what we want from it, because it does some things really, really well.
Yeah, and I think a lot of people don't realize they're using AI sometimes. That I didn't know it was AI that was transcribing my voicemails for me. I knew it was technology, but I didn't know it was AI.
This thing about the best technology being so invisible you don't even see that it's there. The best AI is like, really, that was AI?
Yeah.
Like my phone can tell me which of my photos are of cats, and that was AI.
Yeah, and people are so scared of AI and not knowing that we're already pretty much steeped in so much of it. I think that's kind of what I've been realizing. Like,
photo filters.
Yeah, that's true. That's true. Yeah, and it's interesting to see so many people scared of it, and then so many people so excited about it.
Right.
And I'm kind of not sure where I fall in it, because I don't really use it, but I can see the benefit, especially in science. Clearly AI has provided a lot of tools for scientific research. So that's good. But then there's a lot of ethical questions that come up as we try to make new rules about how new technology is used. So what are some of those conversations around ethical use of AI? That's a really broad topic, I'm sure, not just in science, but we've never had this before. So how do we know what's ethical and not ethical about using it?
And the good news is that a lot of the ethical questions that come up are similar to ones we've had before, like questions around, fairness, or questions around privacy, or questions around consent to like use of somebody's likeness. And so we fortunately have a lot of human history to guide us, and there's a lot of smart people who are talking about how those intersect with AI in particular. Like the whole idea of getting back to the idea of what AI's goal is to make predictions, or to predict, in some cases, the next lines on a web page, or in some cases they have to predict hiring decisions or have to predict parole decisions. And people will sometimes treat these as recommendations. Oh, you should hire this person. And that's not what it is. It's predicting your hiring manager in the past would have hired somebody like this.
Right.
And so there is a lot of subtlety in how we use AI and the different ways in which unfairness and bias can creep in. That's an important ethical consideration, because that's really in play with algorithms that are being used today.
Yeah.
So do you think that seems like one of the best pieces of advice you could give to somebody who's exploring AI is to remember that it's not instructions, it's just predicting something based on past outcomes that it's learned. Mm-hmm. So like I was Googling as a student today something, and the AI, snippet came up first, and we were both like, we already knew it was incorrect because we were looking at something scientific. We're like, no, it's wrong. Yeah. But it's predicting that that's what you might want to know. So I think remembering that it's not retrieving information and kind of consolidating it. It's just saying, well, this is what would have happened in the past, so this is what should happen now.
It's generating something new.
Yeah, right. And I think hearing you phrase it that way kind of helped me. Like, I still struggled to understand what it was actually doing, but that makes so much more sense and helps put how we use it into perspective as well, I think. Yeah, yeah.
And so, but the technology itself has really been revolutionary in many ways because it's helped us with a lot of things. I know that in my field in particular, in terms of protein science, biochemistry, this has been a huge revolution for many of us to solve some of the big problems. And in fact, just very recently, 2 Nobel Prizes were announced that have something to do with AI or machine learning, and it was physics and chemistry. So can you tell us a little bit more about how you feel about this? Like, tell us a little bit more about it, and do you think that they're well-deserved?
I know the physics Nobel Prize. I mean, it's kind of weird to see that come at, machine learning. There isn't a Nobel Prize for
computer science.
Exactly.
Yeah, exactly.
So it kind of things get shoehorned into physics. So that's been the main complaint I've seen. I don't think anybody's complaining about like the influence of the people who got this physics Nobel Prize.
Sure.
And the chemistry Nobel Prize was really exciting to me because this is, had already been my go-to example for, hey, a cool specific use of AI to solve a problem that's really well suited for AI. And the chemistry one is like, yes, other people think so too.
Yeah, that's definitely a victory. And I think it's really important just to highlight the difficulty of the problem in biochemistry that AI is now solving. And that's just taking a string of amino acids that kind of looks like beads on a string, essentially, and then telling us what is the ultimate 3-dimensional structure of how those beads are going to come together to form some sort of functional unit that is the protein. Of course, proteins are really important in all of biology. They do almost everything in our bodies, from digesting our food, moving our muscles, everything. And so, huge problem that's been a problem for decades. Well, ever since really the field of biochemistry started. So what's really nice here is that we're hearing some examples where AI, big fail, right? But also, and in a very funny and ridiculous way, but also there's some really good ways to use it. And, the Nobel Prizes are kind of recognizing that. And I think another one that I have used a little bit, because I'm not a programmer, is in generating code for programmers. You can say, I want a program that does this, especially if it's something simple and not really complicated. And I don't know if you've actually used it to generate code if you're programming at all. What you think about that?
I think there's, for simple snippets and trying to get these patterns right, it can get you the answer very, very quickly. I have seen, people who are using it in industry or for commercial things, which would be, one of my main applications, cautioned against using that code necessarily because this AI generated code tends to sometimes have security leaks in it, and security problems, and it also can tend to be lifted almost verbatim from other code repositories, some of which have restrictive licensing where you can't just reuse it willy-nilly in a commercial product. So there's I've seen people use it, and I have not used it very much myself for that reason, actually.
Yeah. Well, I didn't really think about this idea of like copyright and it could just lift it. But you mentioned something about that with image generation, that it can kind of just lift images from other places and say, hey, I made this.
Yeah, that's right. I've got your Italian video game plumber right here.
Oh, that's great.
Yeah, I've seen some really crazy AI generated pieces of art that are really freaky sometimes. Like the lack of ability to construct a what's the I don't remember what it's called, but like almost looks human.
Yes.
Uncanny Valley.
Yeah, I feel
Yes.
like I've seen a lot of AI stuff like that, and it's so unsettling in some ways. And then there's other AI art that seems more reasonable and it's harder to catch. And I've seen so much AI generated images, especially with I don't like, not propaganda, but in like politics, like people generating these images quite a bit for use in that kind of thing to convey a very specific image.
Or
that
weird spam as well. That's another kind of thing.
Yeah.
But yeah, disinformation, weird spam,
yeah.
like, copyright and, the rights of the original artist whose work was used to train this aside. Like some of the uses that generated text and generated images get put to is like really weird and unsettling and highly spammy. Like it's tailor-made for generating a lot of content that sort of resembles the thing that you are searching for and can fool you into clicking. And so it's weird.
Yeah, one of the big ones this past year was Kate Middleton posted a photo of her and her children that then was kind of suggested to be AI generated, and everyone says always look at the hands. AI gets hands wrong a lot. Is that true?
Yeah, especially earlier on, you would get cases of, unusual numbers of fingers or multiple, like, that used to be one of the things you could look at. I think because this is known to be a thing, extra effort has gone into that area, so it's a little harder to, or the edges of like hair strands and things, those tend to look a little weird. It's like, something above and below the strand of hair don't quite line up anymore.
Why is that? Why is there like very specific things that can be telltale AI signs?
AI generated images are really good at the sort of small scale details and textures. And because a lot of the math behind it is built on repeated chunks and repeated textures and patterns at different scales, if you have like a repeated item like fingers, you tend to get extra repeats sometimes. And it's just part of this kind of periodic math that's underlying them, especially in the really earlier ones when you get into a weird space where it's kind of struggling to generate. You would get these kind of characteristic black and white periodic bars. It almost looks like an angry cuttlefish if you happen to have seen one. They're like this distinctive sort of periodic pattern.
Right.
So
just the fact that it knows that fingers usually come in bunches, that
it'll
it's just gonna
keep going.
Make a bunch of fingers.
Yeah, the more bunches, the better.
And I can imagine that it's training sets. Sometimes if I have my arms crossed, maybe just a couple of my fingers are all right. So it doesn't know that people normally or typically have 5 fingers to one hand, is my guess, right?
If it's varying a lot, it's very confusing
it's
for
very
the
confusing.
algorithm.
Oh,
It's
poor
like just
guy.
throw all the fingers in there and just hope for the best.
Right.
Yeah.
So it seems like we're kind of dealing with like a 2-year-old.
I think we're a little. I think 2-year-olds are more competent.
More
in many
competent.
ways.
Yeah, that's true.
Yeah, that's
Maybe
true.
Maybe 2-year-old throwing a temper tantrum, or just like drawing a picture.
Yeah, I think your work on AI and the way you're describing it, it really is, I wouldn't say dumb, but it is artificial intelligence. It's not human intelligence. It's so very different, and it can do things, but it does them, when it does them wrong, it does them very, very wrong. It seems like.
Epic.
I think the thing that makes them look more complex and capable than they are is that we've got some problems that are really well suited to solving with AI. Protein folding happens to be one of them. Chess is another of them, and playing Go and math some kinds of math and prediction,
Right.
statistical prediction.
Right.
And these tend to be things that we're like, oh, a chess player, very, very smart. And we've had these algorithms that can beat humans in chess since like the 1990s.
Right.
But we have the sense of prestige and like fluent text, fluent speaking as well. Like as a society, we tend to associate that with higher levels of intelligence or at least education. And in the case of AI, it's not really a sign of deeper understanding. It happens to be generating fluent sounding text is relatively easy, these kinds of patterns.
Right.
But it's the deeper meaning, it's the context, it's the not misunderstanding somebody's McDonald's order and giving them $250 worth of chicken McNuggets.
Which happened.
Yeah, which happened.
Yes.
Wow.
Yeah, so some of the bigger issues that do come up are things with like racial bias, gender bias, maybe non-native English speakers. Those are the people that tend to suffer from the use of AI in some of these circumstances, like hiring processes or potential plagiarism or use of AI to generate essays and things like that. So is that how active of a problem or active are researchers and computer scientists trying to solve that, or is that just kind of an inherent thing we have to accept about AI?
I don't think it's a thing we should accept. And there are smart people who know what some of the solutions are. And in some cases, the solution is don't use AI because we can't come up with a data set from what we have available where we can get rid of this bias. And or sometimes the answer is you have to audit your algorithms for bias before you can use them. In some places that's required by law. It's kind of tricky to do that auditing as well. So, but there are people working on it. I think there's more there's more knowledge of things we could be doing and things we should be keeping in mind than there is motivation among people trying to sell these things to actually take this into account. So I think we do have regulations in place about cheating people, about unfair decisions,
hiring practices.
Yeah, exactly. Yeah. So some of those can come into play and help, and I think there's efforts in the government to get that going, but there's a lot of kind of willfully playing fast and loose with that too. And unfortunately, some of these decisions are really harming people. And so, you think of false positives from facial recognition in law enforcement. And those algorithms we've known for about a decade by now that, these algorithms are biased and they are less accurate on people with darker skin color. And yet these are still in use in law enforcement, and we can measure the effects of these.
Wow. Yeah, that is unfortunate that it's not being addressed as robustly as it probably should be, and that people are being harmed by it. And yeah, I really appreciate your point that you've made that maybe we just shouldn't use AI for certain things. And it seems like everyone's trying to AI everything.
Yeah.
And I don't know. I think humans, obviously those biases exist because humans train them and humans are biased. And so that's part of the problem as well. But
right.
Yeah, that's unfortunate.
Yeah.
So, Janelle, you are a Rust Belter. You grew up in Michigan.
That's right. I grew up in Southwest Michigan, among the apple trees and the peach trees, swimming on the beach of Lake Michigan. Yeah, home turf.
Home turf, which is not too far away from here, where we are in beautiful South Bend, Indiana. So tell us a little bit about growing up and how much that influenced what you're doing right now, if at all.
Well, I grew up, in a family full of scientists. So there was always this, not only emphasis on scientific curiosity, but just the knowledge that science as a career is a thing you can do.
Right.
So I mentioned I studied teeny tiny lasers. I'm sure the first time I saw a laser in person was visiting my aunt's research lab at Ohio State. Yes. And she has this lab where she's doing research and it has to do with, lasers for telecommunications. And, she was a huge influence on me and, still is. And, that's, the science of growing things in the field, thinking of my dad's work, doing basically a science education for the university
Right.
to local fruit growers, helping them figure out what to grow and when to grow it and how to manage pests and things, and getting to try the experimental apples hot off the tree in the sunshine. Like, science can be delicious.
Science is
Yeah.
very delicious. Yeah.
Yeah. I've heard you talk a lot, even just at lunch today beforehand, about plants and trees and outside and the birds. How much does going out into nature, which is the opposite of computer science in a lot of ways, how important is that to you for your work? Or is it purely just joy, fun, and it's not something that you do to counterbalance this more robotic part of your life?
Yeah, I do go outside to get away from the work and kind of clear my mind and do something active and see green things. But then I pull out my phone, which has the Merlin bird app, and
yeah,
I'm
that's a
like,
good
what's
one.
that bird? And
Yeah,
it
yeah.
will listen to the sound and identify it using machine learning. Like,
Yeah.
there's machine learning in there. So
Yeah.
it's you can't entirely get away from it.
Right.
So-
They're inseparable in a way,
Yeah.
right? Well, so as a Rust Belter yourself, we have a game that we'd like to play with you today.
Oh.
Yes. The game is called How Well Do You Know Your Rust Belt Home State? So we're going to ask you 3 questions about your home state of Michigan.
Oh, okay.
All right. Are you ready?
Sure.
All right. Okay. All you have to do is get 2 of the questions right.
And I get a prize.
No, you don't get anything.
A badge of honor as a Michigander.
Badge of honor. All right. I'm going to read
The mitten of honor.
the mitten of
See, I'm getting ready.
Get
All right,
ready.
yeah.
Get ready. All right. I'm going to read
Well,
the
go
first
figure.
question. Okay. I read the first question. Are you ready?
Yes.
All right. Okay. So question number 1. As a Michigander, if you want to tell another Michigander which part of the state you are from, do you A, point to a spot on your forehead tracing your hairline? B, point to a spot on your hand? Or C, do an interpretive dance relating to the geography of your hometown?
Ooh. Oh, the interpretive dance, that's Louisiana. You have to get your foot up there to point. Yeah. So no, it's B. It's the hand thing.
It's
And
a
like
hand thing.
also
Yeah.
it's a whole mental thing when you're about to raise up your hand. Like, is this the correct mirror
Sure.
image version? The correct
Yes.
hand-enantiomer.
Handedness, the enantiomer.
yeah,
Yes,
there
this
you
is the
go.
handedness.
Yeah.
And in fact, because Michigan is made up of 2 peninsula,
Pointy bits.
pointy bits, right? You can actually have 2 hands to make
Oh,
signs
that's
for
right. You can you
Yes.
can do like the little finger gun sort of shape for the
Exactly.
Upper Peninsula, and
Yes.
then it's really tough to get them both oriented correctly. But if you do it
Exactly.
right,
Yeah.
you get this nod from
Yes.
other
There you
Michiganders.
go.
Yes,
Yeah.
and you look super silly. So that's what happens. All right.
All right, so you got one correct. I'm going to ask question number 2. When you are at a restaurant in Michigan and the waitress asks you what you want to drink, do you say, A, I'll have a Coke, B, I'll have a soda, or C, I'll have a pop?
The answer is C. I'll have a pop, unless you specifically want Coke. So this is a little bit of a trick answer. 'Cause
This
you
is
can
true.
say Coke,
This is
but
true.
yeah, the pop is a generic thing. Soda is what you put in a cake.
Oh, yeah, exactly.
Yes,
So does
I agree with this 100% as a fellow Rust
Rust
Belter.
Belter.
Yeah, I was like,
Yes. Yeah.
that's not even a question. It's obvious which one is correct.
Well,
Everything
that's
else
true.
makes 0 sense.
All right. So
All right, you
you're
got
2
2
for
out
2.
of 2. Yeah.
Two
All
for
right,
2. All right.
last one.
You ready for question number 3?
Yes.
All right, here we go. According to the laws in the town of Harper Woods, Michigan, which of the following is true? A, it is illegal for a donkey to sleep in a bathtub. Or B, it is illegal to throw confetti or spray silly string. Or C, it is illegal to color birds and sell them as other birds.
Oh, I hope it's C.
Final answer?
This one I don't actually
Yeah.
know.
Well,
I'm going to guess it's C.
Well, the final answer, the correct answer is C. You got 3 out of 3.
Hooray.
Apparently, in Harperwoods, Michigan, it is illegal to paint birds and sell them.
That seems intuitive.
There must have
though.
been an incident.
That's what I'm thinking, right? There must have been an incident. I need to dig into the archives of
Yeah.
that town, right?
Okay, yeah, I guess so. All right, passed with flying colors. Janelle.
Passed with
That's
flying,
excellent.
3
You're
out
a
of
real
3.
Michigander.
Right? This game was brought to you by nobody, because nobody was stupid enough to sponsor a game this dumb.
Yeah, and I'm not going to make the usual joke about Michigan driving that most Indiana people.
Let's keep
We
that
don't-
for a
I
different...
won't
What
stop.
joke? I've never heard.
Yeah, right? Yeah, it sounds like a Michigander.
There you go. All right. Is there anything else you wish people knew about AI that we didn't ask you today, or that you're just like chomping at the bit to say? A story, an example, anything?
I'll leave you with my favorite story, which is a really old one,
Yeah.
but I like to tell it because it just makes me think. So one of my favorite examples of AI solving the wrong problem was this case of a research group that had a algorithm that was supposed to sort a list of numbers, but they had defined success as minimizing the number of numbers in that list that were out of order.
Mm-hmm.
And somehow this program managed to delete the entire list, resulting in 0 numbers out of order, and therefore perfectly solving the problem.
You don't need numbers.
No, and
Mhm.
we just did say that toddlers are more competent, but this is 100% something that my
would do.
middle
Yeah,
school
middle
boys would
school.
do. It'd
Yes.
be like, do your fold your laundry, and
Mhm.
they'll just throw it all away and be like, well, there's no laundry to
There's no
fold. Like
laundry
I
to
can
fold.
see them,
Yes, problem solved.
or
Right.
like literally,
Yeah.
I asked my child, like, okay, can you just wash 20 dishes in the sink? It's overflowing. Can you please wash 20 dishes? So he pulls out 20
Spoons.
spoons,
Yeah, that's what he's
leaving
pretty-
all the big
all
dishes.
the big dishes.
Uh-huh.
Yeah. So this is a true story about my son when he was in elementary school, and they said you have to use the 3 words that sound like there, right? They are, or there, as in
Oh,
like
yeah, okay.
there. And his answer was, I used there, and there in a sentence.
What was the sentence?
That was the sentence.
So I think my takeaway is AI is basically a middle school boy.
Yeah,
like
exactly. It's
trying to
it's a-
do the bare minimum
It's a
and
10-year-old
still
boy. Yeah.
still get it to count as the answer. Like,
Mhm.
yeah, that's my takeaway from this.
That's what you got from
It's
the whole
not a-
thing?
It's not a toddler. It's a 10, 11-year-old boy.
Yeah.
Who's also not very smart. They're not as smart as they
But
think
very
they are.
good
But-
at drawing.
Yes.
Yes.
They're
good.
very good at doing the thing that you asked them to do in the least amount of work to do it.
Least amount of work.
Yeah.
Hmm.
So, all right. Anything else,
Oh.
Shahir? You got any final questions or
No, this has been
anything?
lovely.
This has been so cool. I feel like I understand AI a little bit better. I'm more. Maybe I'll be a little bit more adventurous in my use of AI
I think I will
moving
be too.
forward.
Yeah.
I've dabbled. It's been fun, but I think this is encouraging me to have more fun with it and not take it too seriously and all that. So thank you so much for being here today,
Thank
Janelle.
you
I
so
really
much.
appreciate it.
At the end of our show, we would like to thank you, our lovely listeners, and our awesome audience for spending your time with us. We thank the Notre Dame College of Science and the Indiana University South Bend College of Arts and Sciences. Special thanks to the wonderful people at the Notre Dame Studios. Coming to you from beautiful South Bend, Indiana, in the heart of the Rust Belt, this is Rust Belt Science. I'm Shahir Risk,
And I'm Maggie Fink.
and we'll catch you next time.